So let's do some examples here. It says find the cardinality. Cardinality, again, means how many elements. Of the following sets. So here, if I find n of j, how many elements are in the set j? That's the same thing as finding the cardinality in this. Let's look at the set. How many things do you see? I see 2 elements. So what's the cardinal number? The cardinal number is 2. How about the next one right there? It says find the cardinality of S, where S is the set 3, 4, 5, 6, 7, all the way up to the number 31. Well, here's what I mess with you in class. If we were in class, I would say let's just look at the set 1 through 10. How many numbers are there 1 through 10? And most of you would say that the answer is 10 numbers, okay? Which is good. The numbers 1 through 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, that is 10 individual things. So the cardinality of 1 through 10 is indeed 10. That's correct. But notice, you can't do the high number minus the low number. If you did high number minus the low number, 10 minus 1, it would only say there's 9 elements. So anytime you want to find out how many consecutive elements there are, you're always going to do the high number minus the low number plus 1. And we're going to see this several times this semester, so I want you to get used to this. You're going to do the high number minus the low number plus 1. So how many numbers are there between 3 and 31, including 3 and 31? You would do the high number, which is 31, minus the low number, which is 3, plus 1. So that would be what? 28 plus 1 is 29. What is the cardinality of the set? This cardinality of the set is 29. Okay? Let's do the next one. What's the cardinality of the set T? The cardinality of the set T, how many elements are in there? Well, remember, you have to remove any repeats. And I see the number 3 repeated. So really, we're finding the cardinality of the set 3, 5, 3, 7, 51. How many items are in that set? There's 3 items on that set. And if you didn't notice, several students would have gotten that wrong on the test because they see 4 things, they put the answer 4 without even thinking. You must remove repeats. So again, remove any repeats. Okay. And that's what I kind of emphasize here. It says, note, be careful with part C in the previous problem. Most students would have said n of t equals 4 because you see 4 elements. But remember that the proper way to write a set in roster form is not to repeat elements. I recommend rewriting the set in proper form first with no repeating elements, then determine the cardinality. So very, very important there. Rewrite. Let me use the highlighter. Rewrite the set in proper form first with no repeating elements, then determine the cardinality. Very important there. Okay, let's look at number 12 here. Check your progress. Determine the following. If C equals -1, 5, 4, 11, 13, find n of C. So all they want to know is how many elements. That's all that means. And you can just count them. We're looking for distinct elements. 1, 2, 3, 4, 5. I see 5 separate things. The cardinality of it would be 5. Next one says, find the cardinality of the set containing 0. Well, how many elements are in that set? There is 1 element inside the set, so the answer would be 1. Says if E equals the empty set, find the cardinality of E. Well, that would be the cardinality of the empty set, right? How many elements do you see inside the empty set? Well, I don't see any, so the answer would be 0. Notice I did not put a slash through it. I do not mean the empty set here. How many elements does the empty set have? It has 0 elements. That's the definition of it, right? Okay, let's go to the last topic on this page here. It's the difference between equal and equivalent. In the English language, equivalent means the same thing as. Equal means the same thing as. So it's hard because in the English language, equal and equivalent mean the same thing. But in mathematics, when we're dealing with sets, equal and equivalent are not at all the same thing. So equal means exactly the same. Okay, it's the same number of elements in the same elements. What does equivalent mean? It means only, equivalent means only the same number of elements. Okay. So, how do we denote equivalent? We do an A with this little squiggly sign, a B. That means equivalent right there. And what do we do for equal? We do exactly what we know. We actually put the equal sign in there. So if you see that equal sign, it means they have the same number of elements and they're the exact same elements. If you put that little squiggly line, those things are equivalent. So I'm going to give you a few sets and just mess with you and see if you can figure this out, okay? So I'm going to do set A. Let's call it the set 1, 2, 3. I'm going to do set B. I'm going to call it the set A, B, C. And we're going to do set C, and that's going to be the set A, B, B, C. And I want to talk about these two things. And then actually let's do a set D, which is going to be the set 1, 2, 3, and 4. Okay? So the question is, which one of these sets are equal? Which one are they equivalent? Which one of them are neither? Okay? And I want you to think about the statement. What if I said A equals B? Would that be true? Well, they both have 3 elements, but they're different elements, so that would be a false statement. Hopefully you agree with that. But what if I said A is equivalent to B? Okay, why is it false? Because they're not the same. They're not the same. Okay, how about A equivalent to B? Well, that answer is actually true. Why is it true? Because they have the same number of elements. They both have exactly 3 elements. A has 3 elements. Notice the cardinality of A is 3. The cardinality of B is 3. Okay? Now here's where some people start messing up. Let's look at how about B is equal to C. Is B equal to C? And the answer here is true. Why is it true? Just remove the repeats. If you remove the repeats from C, you would see that it's equivalent or the same thing as A, B, C. The exact same thing as the set A, B, and C. How about A and D? Does A equal D? That's false. Why is it false? They're not the same. Is A even equivalent to D? Well, everything in A is in D, but they're certainly not equivalent. That's false. There's more elements in D. Okay? And we could go back and forth and we can make so many different comparisons here, but I just wanted you to get this idea. I want to stress something else with you as well. Usually it's going to say, is it equal, equivalent, both, or neither? That's usually what the problem is going to say. And I want you to think about these sets. For instance, we just agreed that B is equal to C because they have the exact same elements and the exact same number of elements. So C just had repetition. You remove it. B is equal to C. Remove the repeats and they're exactly the same. Is B equivalent to C? Well, think about it. If you're equal, you have to have 2 things. You have to have the same number of elements and you have to have the same elements. Well, if you have the same number of elements, by default, if you are equal, you must be equivalent. So if you are equal, you must be equivalent. Okay? Why does that matter? Why does that matter? Because if you see a question that says, is it equal, equivalent, both, or neither, I am telling you the answer will never be equal. It's equivalent if you have the same amount of elements. It's both, because if you are equal, you are both equal and equivalent. If you have the same number of elements and they are the exact same elements, and then it's neither if there's a different number of elements. Okay? So if there's a different number of elements, the answer is neither. If they have the same number of elements, it's at least equal. If they have the same number of elements and they are the exact same elements, then the answer is both. So never, ever, ever fail and put the answer equal, because if it is equal, it is automatically both. You're going to see these in the next questions.